Breast cancer has become one of the leading causes of death in women. Currently, it is estimated that 1 in 8 women will be affected. The American Cancer Society's projection for 2016 is that 246,000 new cases will be diagnosed, and more than 40,000 are expected to die. Over the last 20 years, incidence of breast cancer have been increasing until the year 2000, when a slight decreasing trend set on. Clearly, this issue is of major public health importance, which is why it has been studied since the early 50s. One of the first studies conducted by Tenenbaum revealed a positive correlation between dietary fat intake in rodents and incidence of mammary tumors. Based on this and other positively correlated studies, in 1982, the National Research Council issued a recommendation to decrease dietary fat from 40 to 30%. Another study conducted by Prentice examines the correlation of fat disappearance with incidence of breast cancer on an international platform. Data collected revealed a significantly strong correlation to animal fat disappearance and a weak correlation to vegetable fats. Trends revealed higher cases of breast cancer in more developed countries. However, the study failed to adjust for food waste as a reason for fat disappearance. Still, research on this thesis continued for many years with many different research approaches. While there has been shown a slight positive correlation, still there is no significant conclusive evidence to suggest that dietary fat contributes to the occurrence of breast cancer. With any study model, there are always multiple variables to take into consideration and some confounding factors that may not be properly accounted for, one of which is the unknown latency period of breast cancer occurrence. All these have disallowed the definite conclusive study results. Due to the increasing effect on public health, voluminous research has been performed on the association between dietary fat and breast cancer. In an effort to reveal further information, this research has been directed at investigating concerning risk factors that were suspected. There are many points of interest that can potentially contribute to breast cancer occurrence. Dietary fat was a major interest in prospective studies. As presented in the graph, many of the studies and data pools similarly revealed a positive correlation of fat intake and more specifically animal fat intake. However, correlations were not strong enough to be considered significant and absolute. In addition to the aforementioned suspected risk factors, investigation of estrogen levels have revealed positive correlation to breast cancer indices. In this depicted graph, a positive association was found between high-fat dairy and red meat intake and estrogen receptor tumors in the Nurses' Health Study. Also in this case control study of postmenopausal women who were put on a diet of 20% reduced fat intake over an 18-month period showed reduced estradiol hormone levels, a common indicator of breast cancer. While there may be a positive correlation, again, evidence is not strong enough to suggest significant correlation results. As presented in the chapter, multiple varying studies have been conducted on this subject over the last 60 years. The different approaches aimed at investigating any possible relation between dietary fat and breast cancer, executed in a manner to present the least amount of error and the strongest correlation. Over the next 30 years, a prolific amount of research has been dedicated to the association between dietary fat and breast cancer. In 1975, Armstrong and Dahl published data that showed striking correlations among countries between national per capita fat consumption and breast cancer indices and mortality. In 1975, Carroll independently published data similar to that of Armstrong's. These two studies were the primary motivation behind the U.S. National Research Council's recommendation to decrease consumption of dietary fat from 40 to 30% in an effort to reduce cancer rates. However, as we have seen, conclusions from the ecologic studies based on disappearance are weakened due to their limitations. Wealthy and more industrialized countries are likely to have wastage of food and fat that is greater than non-industrialized countries. This wastage is not accounted for in the disappearance studies. Exclusion of such variables weakens association in the studies as potentially confounded by variables like lean body mass, obesity, sedentary lifestyle, etc. Migrant studies were used to determine if the large differences in breast cancer rates among countries, as seen in ecologic studies, were actually attributed to genetic factors. The studies demonstrated that breast cancer rates were not attributed to genetic factors. In a study examining Japanese immigrants to the U.S., observation of immigrant women and their offspring revealed a higher occurrence of breast cancer in offspring, more similar to trends of U.S. citizens, and can possibly be accredited to acculturation. Although one has to keep in mind the limitation of timing and exposure for migration studies to be truly valid, sometimes an exposure is not evident until decades later due to latency periods of disease. Miller conducted a high-quality case study of 400 Canadian women compared to 400 control participants. 3 methods of data collection from known assessment methods were utilized to measure dietary intakes. As we have learned from previous chapters, there is potential for bias when collecting such data, which can be further biased by actual diagnosis of disease. Again, data analysis did not adequately prove the correlation of dietary fat intake to breast cancer risk. Pooled data from multiple case control studies again failed to support any significant relation. Though when the results of various studies were pooled, meta-analysis confirmed some positive association. However, these studies are considered to carry less weight due to recall and selection bias. Phillips and Snowden conducted a long-term cohort study of Seventh-day Adventists investigating dietary habits, and data collected again were inconclusive. Data reviewed by Mills conversely revealed a risk in breast cancer for women who adopted a vegetarian diet earlier in life. The Women's Health Initiative conducted a randomized trial on dietary fat reduction and a possible correlation to risk of breast cancer. One of the limitations was the difficulty to create significant difference in fat intake between a study and control group, though after 8 years the observed difference of risk in breast cancer between the study groups was small and not significant. Although animal studies have been a primary contributor to the hypothesis, results often are not transferable to humans. Also, animal study findings could be irrelevant or even inversely related in humans. As you can see, the relation between dietary fat and breast cancer has been studied extensively over the last 60 years. Despite this extensive research, there is weak positive correlation at best, while no strong or significant and sometimes even inverse correlation has been discovered. This leaves us to investigate other possible connections to the risk of breast cancer. Our bodies are a complex network of interactions and connections and reactions to what we eat, the lifestyle we live, the genetics we are provided, and the environment we're exposed to. Due to this complexity, there have been many other factors of consideration to the possible risk of breast cancer, like hormonal factors, physical activity levels, exposure to environment, and diet. The recommendations by the National Research Council were the first public policy statements associating breast cancer with dietary fat intake in response to the available research at the time. The recommendation put forth by the NRC was that the U.S. population reduce their percent of caloric intake from fat from 40% of the daily diet to 30%. The foundation for this policy formation was based on early studies, like the ones conducted by Tenenbaum and Armstrong, that seemed to propose positive correlation between dietary fat and breast cancer risk. In 1984, the National Cancer Institute quickly followed the lead and issued a policy in line with the National Research Council's recommendation for dietary fat reduction. As we learned in our reading and lecture this week, many segments of the U.S. and global population do not have direct access to research data and rely on the guidance provided by public health organizations. Dietary reference intakes, or DRIs, did not replace the recommended dietary allowances, RDAs, until the mid-90s. As discussed in our assignments this week, the RDAs were developed by the national academies to address dietary deficiencies, while the RDIs were more focused on chronic disease prevention. It is also important to reiterate that while primary research used in the development of these policies did demonstrate a strong correlation between national per capita fat disappearance and breast cancer, there are several significant confounding elements to this association. Similarly, while some animal trials have shown distinct links between the factors, the question remains how animal cancer risk most directly correlates to the risk of human population. Based on the voluminous amount of effort and funding that have been expended in subsequent decades, primarily resulting in inconclusive or contradictory results, the association between dietary fat and breast cancer is not as affirmative as originally believed.